Hi everyone, and welcome to the fifth in our webinar series, Connection Regardless of Location. This session will focus on the coverage inside stadiums and venues. My name is Sam Dilley, and your speaker today will be Ingo Faloma, one of our product managers here at Axel Wireless. We've got an interesting webinar today, but before we start I have a couple of housekeeping points. During the webinar you'll be placed on mute to avoid any feedback and to help ensure we finish on time today. If you have any questions for Ingo, please send them via the chat option, which you should see on your right-hand side of your screen, and we will get through as many as we can at the end of the webinar. Okay, over to you, Ingo.
Thank you, Sam. Welcome, everyone. I'm glad we have lots of people interested in this topic. My name is Ingo Faloma. I'm responsible for product management and business development in the EMEA region for Axel Wireless. And we look into a topic today that is really interesting, and it's a growing demand to cover Stadia. Stadia are particularly interesting because they represent the highest density of subscribers that we can find in any system worldwide. We will finish this session with a question and answer round, so I'm happy to answer all your questions at the end of this session. Our agenda for the next 30 minutes is first introduction of Axel Wireless. Then we talk a bit about the reasons to cover Stadia and venues and show solutions for it. And close with a case study focusing on London 2012 Olympics, a particular big system, and looking into a Brazil stadium that we have covered for the last World Cup in football. So who is Axel Wireless? Axel Wireless is a global company. We are a manufacturer for DAS, for active DAS systems and wireless coverage solutions. And since last year we are part of COPAM. COPAM is a London Stock Exchange listed company with more than 10,000 staff, with more than $3 billion annual revenue. And most of it is high-tech and R&D related business, very similar to what we are doing. Axel Wireless is providing solutions for cellular, for public safety, and for transport applications, and we do that for over 40 years. Obviously, the subject of business has changed over the years, so now it's more capacity driven. In the early days it was purely coverage driven. We have maintained our focus, which started to be quality 40 years ago, since we were mainly active in the defense business. And this quality approach has survived, and this is still our focus. So we are looking on innovation, and we are continuously improving and trying to lead new solutions in the market. We are presented in more than 150 countries in all continents. More than 170 mobile operators are buying from us, and this is a growing number. We just maintain 16 offices worldwide. We have a sub-layer of partners, a big partner grid, being in contact directly with the customers. So that expands our sales capability a lot. Same with employees. We run our organization with 250 fixed employees. Reason for that relatively low number is that we have outsourced most of the production process and some of the sales process. So these 250 people are mainly engineers. We have a high content of R&D in this number to maintain our innovation stream. ABI is a company researching telecom markets, and one of their subjects is analyzing the in-building market worldwide. And we are really happy that we were listed as number 3 in the overall volume in this market. We are happy with it because we are the biggest European manufacturer, and we are just below 2 giants, industry giants, who manufacture cables, antennas, mechanical parts, and many things that Axel doesn't do, because Axel fully concentrates on active equipment. So we are pretty happy with this number 3 position, and what makes us even more proud is the ranking on the innovation scale. We are ranked innovation leader And this is mainly due to our latest release, a digital distribution platform, IDDAS, which we have launched in Barcelona this year. So who benefits from stadium and venue coverage? Of course, we all know that we benefit from it. I just try to break it up a little bit to show the different motivation with the different stakeholders. So for the visitor, it's the most easy. It's uninterrupted connection to the outside world through voice calls, text, email, internet, and so on. It provides safety and a secure environment. And future applications could use NFC, for example, for promotion. So there is a future potential in this wireless approach. For the mobile operator, it is a higher customer satisfaction due to network availability, increased revenue with premium standard and roaming customers. So who goes to high-class sports event? It's usually premium customers. And there are lots of roaming customers in international events, and you want to catch them and keep them on your network. It increases brand awareness. And what we see also is in many stadia are hosted by operators and named after operators, and that gives additional marketing benefit. And of course, if you do that, you need excellent quality and coverage inside the stadium. For the stadium owner, it's greater customer satisfaction. The network can be used for promotion and to provide information, and it makes the venue favorable over other venues. So you can really set a benchmark here by providing excellent communication in such a stadium. The requirements in the stadium are very unlike other in-building systems. This is mainly due to the very high density of users. There are stadia with more than 70,000 people, 90,000 people, even 100,000 people, and they generate a peak traffic very similar to a quite large city, 500,000, 800,000 people, and that on this small space. And that's where the challenge starts. You have to deploy multiple cells in a very confined space. Also, the traffic per user is exceptionally. It's usually much higher than in the outside world. Users do not move much. That's another complication. Users sit at their place. That means you will not walk out of a bad spot. If you are covered with bad quality, you will have this bad quality the entire time of the game. So that gives additional targets that have to be fulfilled to provide excellent quality all over the stadium. Absence of clutter makes cell isolation very difficult. As you see here on the picture, you have basically no isolation between all the cells you have to distribute. That means you have to use other tricks to maintain a good quality in such an ecosystem. So the target is to optimize the throughput, and you do it by maximizing the signal to interference, which is obviously a quality target. And this will result in fast data rates, and those fast data rates will reduce the connection time for each user and allow for more overall capacity. So you see, we are pulling every string to get as much capacity as possible. It's as many sectors as possible, but it's also the best quality possible, because every reduced aspect in quality terms will reduce the throughput and require more overall capacity. So we want to show now how this can be approached. We're talking about the bowl here, the seating area of the stadium. Usually you attack it from the roof, because that's the position where you have a line of sight distance to the spectators of such a stadium. And that's a point where you can mount antennas relatively easy and without much interference, because that's a point where the direction of the antenna, the beam, points to the outside of the stadium and not to the other side of the stadium where it would create interference. So how many cells do you need in such a stadium? There is a rule of thumb. I use the 2,000 spectator rule per cell. That is for pretty heavy utilized Stadia international events. There you can count with 2,000 subscribers per cell. In regional stadiums it can be a bit more relaxed, like 3,000, 3,500 subscribers per cell. But what I want to say here is that it can easily result in 40 plus sectors in the bowl in the stadium. For that you need narrow beam width antennas, because obviously each cell is pretty small and narrow. Fortunately, there are dedicated stadium antennas on the market. So what is different with these stadium antennas? Main target is to create a defined coverage spot and no side lobes. So that's what it's all about. You want 100% of the cell signal in the defined area, and you want 0% outside. Of course, physics doesn't work like it, but stadium antennas try to become near that, and we can see results later. The target is to avoid interferences by precisely defined small cells with high isolation, and that's not only caused by the antenna itself, it's also caused by the position where the antenna is mounted. So it needs quite a lot of optimization to get the stadium up to speed. So you try to optimize throughput by maximizing signal to interference that directly relates to the antenna position and the antenna type. And fast data rates will reduce the connection time and allow for more overall capacity. So message is, antenna design is crucial. It's more crucial than selecting the right active DAS system. The footprint of the antenna depends on the distance to spectators. The wider the distance, the less sharp the cell definition is. Typical positions are near the loudspeakers, because that's obviously where the rules are the same. The sound wants line of sight, and we want line of sight for our RF system. However, what happens at these positions at the end of the roof that is shown here with the antenna symbol, it's an area with reduced weight load, with reduced space, usually not so much power supply availability. So it's not so easy to feed such an antenna, or it's actually not one antenna, it's 40 or more antennas around the stadium. So what options do we have for that? One option would be to run a feeder cable to each antenna and put the base stations somewhere. Not the best idea, because you will need lots of base stations. Imagine a scenario with 4 operators and 4 bands each. You would need 16 base stations that have to be connected on a high power level and put on a feeder cable and brought to the antenna. Hold on, you might say, we can use remote radio heads. Of course, good idea, but you still need 16 of those, and they need to be located close to the antenna, because reduced cable loss means increased uplink throughput due to better signal-to-noise ratio. And usually the weight load is not permitting to put 16 remote radio heads at the end of the roof. That's where the active DAS comes into the game. Active DAS requires just a single box remote unit, as shown here on the picture, to support 4 bands in one box, multiple operators, multiple channels. So the entire cell capacity can be delivered by this single box of an active DAS system. And the distance to the antenna, the cable distance, can be very short. It can be 3 meters or so. That means the uplink loss, the passive loss before the receiver, is reduced to a minimum, and that ensures high uplink throughput. It's very easy to adapt capacity with such an active DAS, because you can segment it different for every operator and for every service, and the next slide will give more light on that. So let's assume there is a Tier 2 operator with a smaller subscriber base. This operator can provide large sectors, for example 4 sectors for such a stadium, because then he has no handovers between the cells. He can reutilize the frequencies better. We use less base stations, so it's an optimized solution for a small operator. On the right side, we see an approach for a big operator. A big operator has more subscribers in this same environment. He wants more capacity in the stadium. So in this easy example, he's using 10 cells to provide coverage to his customers. And what I'm saying here is that the same remote unit and the same active DAS can be configured in both ways simultaneously. So the small operator is applying a large sector pattern, while the big operator is applying a maximum number of sectors approach. And it's not just between operators how you can select this. You can also select it between services. For example, you could use large cell strategy for GSM 900, while for UMTS 2100 you use a small cell strategy with maximum capacity. And all this can be mixed in one system. So what are the results with such a system? We try to show you some measurement results from London Olympic here. This was a system driven by Axel Wireless MBF40 active DAS with special stadium antennas. And what we see is that the cell definition is pretty sharp. You can't do it much better than shown here. What is cell definition? It is the overlap region between these green elements. So everything where the color is not green, we are in an overlap situation with reduced quality. The ideal case would be to have no color than green, but obviously physics speaks a different language. So we have overlap zones that have reduced quality, but together with an active DAS and a good antenna planning, you can minimize the overlap sectors. On the left side, we see the best serving sectors. So they have pretty much the same dimension. Actually, this is just 1/3 of the stadium that we have monitored here, because it was kind of a balcony structure. So we had this same scenario 3 times in that stadium. Further, we apply the idea of the BTS Hotel in every stadium. BTS Hotel means that you have a single room or single building with all base station capacity in the same building. This building can be outside the stadium or at any place that is easily accessible and connected with fiber to the remote units. The advantage of this concept is that you have easy access to the base station equipment anytime, even during the event, because then it's most critical, and the risk of failure is highest in the BTS equipment because it's most complex. So you want access to these devices. They shouldn't be on the rooftop where you can't go during the event. The BTS Hotel further has the advantage that you can reduce CAPEX and OPEX by sharing air conditioning, sharing power supply and power backup, sharing the space. So there are a lot of synergies. Inside the base station hotel, you have not only the base stations, you also have the master unit of the optical distribution system. And here we see what's inside. It all starts with the BTS because the BTS provides capacity. And this capacity goes into a master unit. The master unit is the interface between base station and the active DAS. First element inside the master unit is the point of interface, the POI. It combines sectors, it adjusts levels, it basically refines the RF signal and makes it fit for the further process. And we have launched this year the APOI. It's an advanced POI with an algorithm inside that can automatically level the signals coming from the base station. That is a growing requirement to have such a functionality because more and more systems are operated by neutral hosts and not by operators knowing their equipment perfectly. So APOI can be used even when you don't know how the base station is configured, how many TRXs there are, what traffic load the base station has, or what backoff the base station has. You can just connect it and the API will take care of the leveling. And the API feeds the OMU. The OMU converts RF to optical, so it has the laser modules inside. And the Axle Wireless OMU has a specific advantage, which is that you can put up to 8 lasers into one 19-inch subrack. So that gives a very high integration density, and you can reduce footprint of the master unit further. Each remote is connected with a single fiber to the master unit. So on this single fiber, all the information travels from all operators from all bands for that cell that is distributed by that single remote unit. And when you want to change the sector pattern, you do it in the base station hotel, because that's where you say, okay, operator A shall have 1 cell per remote, operator B might have 1 cell on 4 remotes. And you can easily change the configuration in the base station hotel. Everything is controlled with a web server approach. So you have a GUI that is transparent, that allows to monitor many parameters. And one word about supervision, because that's a critical element. You have to bring up a system in a short time usually. Supervision might take a long time to get accepted by your network operation and so on. All Axle equipment can be monitored by SNMP, by any standard umbrella system. Of course, we have our own OMC system that we can deliver that can reduce workload by having functions that make supervision easier. But you can use SNMP to monitor the equipment. You can use SMS forwarding. You can also directly connect to the equipment and use the web server to monitor the equipment. So let's look into 2 case studies here. One is Olympic Park in London. It was during the London 2012 Olympics that Olympic Village was defined. This village consisted of multiple sites and venues, and there was one unique thing here, and I believe it was worldwide the biggest in-building coverage system, with more than 350 remote units connected to one single base station hotel. So this project followed all the recommendations and requirements of the Olympic group for cellular coverage, but we also provided public safety coverage, and all UK operators participated in this system. It was using 900, 1800 and 2100 because there was no LTE license active at that time. The amazing thing is the base station hotel. It was a 2-story building full of BTSs, and believe it or not, it was 970, actually a little bit more than that, more than 970 feeding base station sectors into that system. That's an enormous amount of capacity. So these 970 feeding base station sectors were distributed to more than 300 remote units. The benefits: deployment covered 1/3 of a million seats at its peak. No operator experienced service degradation or network performance issues, and millions of visitors were provided with seamless connectivity. And I want to add that this system was monitored and serviced by Axle Wireless. We had the entire system in our internal OMC, and we had the service staff out in the field to take immediate action if there was a problem. A more recent case study, the Maracanã football stadium in Brazil. In brief, we worked with our partner RFS to provide reliable cellular coverage to a variety of stadiums in Brazil. So it was the 2 largest, Maracanã and Mineiro Stadium, and we deployed a system that can cope with the extremely large volume of uplink traffic due to fans posting photos and videos online. Studies have shown that in Stadia, the uplink traffic can be higher than downlink traffic. Obviously, people are sending a lot of information to friends and sending videos. So it's a bit untypical, the traffic behavior. But what does that mean? Uplink traffic is a very sensitive issue. You cannot overcome an uplink traffic problem by increasing the power. Uplink traffic problems can only be solved by increasing the quality and the signal-to-noise ratio. So what I want to say is, with the active DARs, you can achieve excellent uplink throughput ratios and performance. The solution here again was an MBF40 system, same as in the Olympics in London, but obviously with different frequencies, because this is an American system here. And it was a multi-band system, multi-operator, using the same optical master unit that we have shown before. And in this case, it was 2G, 3G, and 4G services inside the stadium. So the benefit is a world's leading fiber DAS system that is future-proof, providing them with the option to make upgrades, because that is what's going to happen. The initial slides I showed before were taken from a big stadium in Europe in 2006, and they just deployed 10 or 14 sectors or cells in each stadium at that time. And usually a big event cycle is 2 or 4 years. You can be sure after 4 years the requirements for capacity are much higher than they were before, and then you need a system that can be upgradable. And with an optical DAS and active DAS, you can relatively easily upgrade the system. So millions of visitors were provided with seamless connectivity in this stadium. And that was a little overview. We have done many more stadia. We are doing new ones almost every month. We are doing a big one in the UK right now with MIMO. So that is the first stadium where we see that there is a direct MIMO requirement, and it is quite a big one with more than 50 remote units. I hope that this session gave you some insight. I know that we just covered it very briefly, but we are available. We in Excel Wireless are happy to help you with your requirements, your specific requirements. I now hope that you have raised questions, that we can all participate in your questions and get even more information. I want to say thank you already for your participation, and I'm looking now for the question and answer round. Thank you.
Thank you, Ingo, and thank you everyone for listening. Yes, we have had some great questions come in, so I'll get right on to them. First question I've got is, do you see a trend in stadium coverage? Is it remote radio heads or active DAS?
Yeah, that's the typical question, and there is a culture. In some areas there is a remote radio head culture. In some areas there is a strong active DAS culture. I just can reflect what I've seen in some stadia covered with traditional base station technology. The customers complain about missing capacity, drop calls, and so on, because it's more difficult to provide the same cell density than it is with an active DAS. So I see a strong trend for active DAS systems because they are more flexible in terms of number of bands, and evidently by weight, by power consumption and size. So it's better controllable to have a base station hotel approach with all the capacity bundled in one room. So I see a big future for active DAS systems. And what I have not mentioned before, you have additional transport channels. The Excel Wireless MBF40 solution allows to maintain a transport channel, a 1 gigabit per second transport channel to each remote. So that can be used for future services when there is a 5G system or 3.5 gig system, to connect an access point or something to this unit to upgrade it in the future.
That's great, thank you, Ingo. Okay, the next question I've got is, how the remote unit handles the MIMO signal. Do you need to use multiple remote units to support MIMO?
Yeah, actually we don't need 2 units, but what you should have is 2 passes, 2 physical passes to totally isolate the MIMO paths A and B. We're talking about 2 by 2 MIMO here because everything else is a bit complicated from the antenna perspective, from the feeding perspective, and so on. So 2 by 2 MIMO is getting more and more common, and we have different approaches here. If it's just single band or low bands, we can do MIMO in one box. But this is not the typical case. As a stadium is going for maximum capacity, you want all the bands, and then we have a quite clever solution. Since our cabinet strategy is based on 4 bands, we can deploy 4 plus 4 bands on 2 different fibers, and we cover the entire European spectrum with MIMO, because altogether that represents 8 bands, and that's what we have in Europe. We have 5 bands, frequency assignments, and 3 of them are LTE in most countries, so we need them double. That makes 8 bands, and that we can provide with 2 boxes in a really attractive form factor.
That's great, thank you. Right, the third question I've got is, do you support public safety solutions for stadiums as well?
Actually we do. It's much more simple than cellular, because obviously the capacity requirements are not so high. It's basically the same approach as we have shown here, but you have much less headache because the design of the antennas and the positions are much easier to solve. What is not typical is a shared system. It's technically absolutely possible to share public safety and cellular, but we don't see it much because of the totally different cell size and location and responsibility. So for a stadium, it's maybe not the best scenario to share cellular and public safety.
I think we'll leave it there for now. If you do have any further questions for Ingo, his details are on the slide in front of you right now, so please do feel free to get in touch with him, and I'm sure he'll be more than happy to help. Thank you for joining us, and yes, we hope you join us on the next one.